On number 7, we end up getting our y-intercept is at 0, -6, and we see that right here. Okay. Also, we see it on our graph. Okay. Again, our x-intercept showed up on our graph, but we also knew that because it was on intercept form. The only other thing besides graphing, connecting these dots that we would need to do is we would need to identify how this function is opening, how our graph is opening, and this one opens up. Okay, so sorry, this was a pickup from the last video. If you will, go ahead and pause the video, try 8 and 9 using the same process that I went over number 7 with, and then check your answers. Alright, here's the answers to number 8. So you see all those characteristics that we were talking about on the right hand side. I've got my table, and my graph shows my x-intercepts, my y-intercept very clearly, my vertex, and my axis of symmetry. So everything is there. And then here on number 9, same thing, you've got our characteristics there that we needed. My table shows my intercepts. I didn't put my x-intercepts on there. I could have written at -4 was 0 and at 2 it was 0, but we already knew that from the form itself because it was in intercept form. But you clearly see my x-intercepts and my y-intercept and my vertex labeled or plots pointed, so everything is there that we need. Alright, so that's a recap of the graphing. Then we've got down here, starting with number 10, we are looking at doing our converting from one form to another. So number 10 and number 11, these ones are in standard form. So please remember standard form, y equals ax squared plus bx plus c. Intercept form, remember that means it's in its factored form. So that means it's going to need to be written as y equals a times x minus p times x minus q, where when we set those factors equal to 0, we get our x-intercepts. So all we need to do is we need to know that if we are going to intercept form, that means factor. So that means we need to factor these. So that means go through GCF, dots, busting the B, grouping, okay? If you call it diamonds, then call it diamonds. So if we look at number 11 and we say, okay, well, what do we have that we could factor here? Well, we have a GCF. So there is a -3 in common with all three terms. When we factor that -3 out, we get x squared plus 9x minus 10. And then we need to continue factoring that trinomial. So we're asking ourselves what two numbers multiply to give us the -10, but at the same time add to give us a -9. Okay, and we should be coming up with a -1 and a +10. Okay, then because we know that our a value is 1, we can jump straight to our factors. So we get an x minus 1 and an x plus 10. This is factored form. We're not doing anything else. All we were doing was factoring the problem. Likewise, for number 10, there's no GCF, so we just need to be able to go straight to the factors. So we're asking what two numbers multiply to give us -6, but at the same time add to give us a 5. And we should be getting that this is going to be a +6 and a -1. So this is the factored form. Okay. On converting our equation from standard to vertex form, so remember, sorry, vertex is misspelled. Vertex. So remember, vertex form is going to be in this form, y equals a times x minus h squared plus k, where the h and the k are the vertex of our problem. So the h is the opposite of what we plug in, the x of the vertex, and the k is exactly the same, and it's the y of the vertex. Okay, and then your a is exactly the same as your a from standard form. Well, how do we get a vertex when we're in standard form? Okay, to get the x of your vertex, we're going to do negative b over 2a. That's the same as our axis of symmetry. Then we can either use a table to find the y that goes with that x, or you can plug it in. So it's really your preference. So we know that a is a 1 and b is a negative 6. So our axis of symmetry, so the x of our vertex is going to be negative 6 over 2 times 1. This gives us a 6 over 2, which is 3. So right now we know our vertex has an x of 3. So we need to find the y. So let's just make it a little simpler on ourselves. Let's take the form that was given, so x squared minus 6x plus 2, and on our table, how about we just start it at 0, and we can either do auto, or you can even set it to ask. Either way, we just want to go to where the x is 3, and we see that the y is negative 7. Okay? So that means all we do is we plug in. So our a is that 1. Okay, so you can put a 1 there, you don't have to. Then we have our x. Then we are using, this is our h, but we have to do the opposite sign. So we're going to be putting in the opposite of 3, which is negative 3, squared. And then this is our k, that goes at the end, minus 7. Okay, you take a second, pause the video, do the same thing. Find the vertex for 13, then plug in the a and the vertex. Alright, so on 13 you should get a vertex of negative 1, 3. Then you can label your a as negative 2, your h is negative 1, and your k is 3. So just remember, when you plug each of those in to these 3 places, the thing you have to do is take the opposite sign for your h, the one with the x. Alright, so then we've got 2 more here, and these ones are converting from whatever form it is to standard form. So that just means you need to do whatever the operation is that's being asked. So here we're being asked to multiply. So here, anytime you are going to standard form, this means do PEMDAS. You need to simplify this so it is all multiplied out and everything, right? On number 14, please make sure you know the 3 does not get distributed to everything, only to the set of parentheses that it follows. Okay, so we're going to distribute this 3. So y equals 3x plus 6. And then this second set of parentheses. Okay, if you're someone that likes to do a box, feel free to go ahead and do a box to do your multiplication. You got a 3x plus 6 on one side of the box and an x minus 4 on the other. This gives us 3x squared. This gives us a positive 6. This gives us a negative 12x and a negative 24. So when you combine the like terms that are here in the middle, we're going to write it out, and it gives us y equals 3x squared. Negative 12x plus 6x is a negative 6x minus 24. Okay, we don't want to go any farther because we want it to be in the form y equals ax squared plus bx plus c. That's standard form. Okay. On number 15, you have to make sure you do the order of operations correctly, which says you need to take care of the piece that has the exponent first. So those of you, again, who are my people who like to do a box, you would do a box. Otherwise, my friends would do x plus 3 times x plus 3. And I'm going to do it over on the side. So x times x is x squared. X times 3 is 3x. 3 times x is another 3x. And 3 times 3 is 9. So this part's going to give us x squared plus 6x plus 9. So that's what replaces the blue highlighted. Alright, so we've got y equals 3 times x squared plus 6x plus 9. And then outside the parentheses is a 5. So order of operations says what we do next is we do the multiplication before addition. So we're going to multiply, which is distribute this 3, only to the set of parentheses that follow, 3x squared plus 18x plus 27 plus 5, and then we can combine any like terms that are left. So we get 3x squared, y equals 3x squared plus 18x and 27 plus 5. Sorry, 8 is 32. Okay? All right, so that helps us figure out how to put things in standard form. These last two right here are giving you a graph and asking you to match. So what I like to do in this case is look at what we're given. We are given, for 16, standard form. From standard form, we know that this right here is our y-intercept. So I would start by saying, okay, they have to have a y-intercept of 7. So far, A is good, B is out, C is out, and D has a y-intercept of 7. So far, we are down to A and D. The next thing that I would look at for standard form is where our axis of symmetry is. Remember, we're going to do negative b over 2a. So this is going to be a negative 4 over 2 times 1. This is a negative 2. So that means we should have an axis of symmetry at negative 2. Well, A looks good. And if we go down here, this axis of symmetry is at a positive 2. So that's not okay. So that means our answer for 16 is A. Similarly, on 17, we have to know what form it's given. This is vertex form. So that means from here, we know the vertex. The vertex is going to be the opposite of the h, which is a negative 1. And then the y is the k value at the end. So let's find all of them that have a vertex at negative 1, negative 4. Well, A does not. B does have a vertex at negative 1, negative 4. C does not have a vertex at negative 1, negative 4. And neither does D. So that eliminates everything except for B. So we know that B is the right answer. Okay? Hope this was helpful. Take some time, go back through whichever ones that you need, and have fun.